My name is Oleg, and I am, as it's written here, site reliability engineer at Eno Games. Yeah, let's just say sysadmin. This will make it much easier to understand what am I doing. And yeah, so I will try to explain how we're using Go here. As you can see, I prepared for today because I very much love Go, and yeah, my colleagues know about this. And yeah, let's go. So just short story, very short, what we had before. So I joined Eno Games like 3 years ago, and we had no Go at Eno Games back then. Like no projects were used, but I mean Go is pretty fresh, pretty new language, so no blame on Eno Games. But yeah, still, so we didn't have Go back then, and now we actually have a lot of Go. We are using it quite actively in sysadmin department, and our developers already writing some stuff even for production in Go, which is very, very good, and we have plenty of projects, and we are this big Go Docker Linux family that we have. Not fully, but yeah, we are coming to it slowly. Yeah, anyway, so we are happy and eating cookies. Anyway, so let's talk a bit about infrastructure. We are using Debian in our company, and Debian sucks very much with Go packages. They are always outdated. You cannot have really fresh one. You can use backports, but it's most probably, for example, for JC, which is the previous Debian version. They had only 1.7, and it's now 1.8.3 or even higher released. So it's pretty much outdated, and for Go, every update brings a lot more stability, a lot more features. So we kind of want the fresh, as fresh as it's possible, and for this we use Jenkins. We basically just repack Go to Debian packages, and we have automated Jenkins job which is doing this. This is pretty easy, and it puts the package into our Eno Games repository, which we have internal Debian mirror, and it puts it there, and it's working fine. We just install it on our builders and build it there, and Teams Jenkins are usually just installing this compiler on those builders and compile their application. So we have those builders connected as Jenkins slaves. You all know what Jenkins slaves are. And yeah, it's easy, transparent, and nice. So it doesn't require very much of clicking or hacking. Doesn't have to. So we have pretty happy family here. Yeah, so how to do all of this? It's pretty easy. This is basically whole complete job of Go installation. It's not something like with Java when you need to accept the license from Oracle and you cannot script it properly because it gives you different hash all the time of your acceptance of the license. Here it's pretty simple. You just get, or curl, or whatever you like, tar it, untar it basically, and unpack it and put it to the package. That's all. And whatever the way how to create the package is on you. And our jobs, which are using Go, so our software, I will go as far as I can, is even simpler. Basically, we are trying to run test-driven development. So first we write test, and then we have the application. And in fact, it's like running tests for the job name, which is variable from Jenkins, basically, and go install. So you get the binary, and then you distribute it with the package. It's pretty easy. So this is basically our Go infrastructure, which is pretty simple, I must say. But it brings us a lot of cool things. For example, we are using projects which are completely written in Go. For example, Graphite. You all know Graphite, but you most probably know it as a Python project. No, it's not. It's for quite some time rewritten to Go, most of its parts. There is web interface still written in Python, but it's there is already the copy of it with not all functions, but most of them written in Go, and it's pretty usable, I must say. And for example, this is writer, and of course more of them used already in our infrastructure, and we send sometimes from time to time patches to the maintainer of the package. Then speaking about Graphite, we have GraphZine. This is a small client, small proxy, which is running on every single server in our company, and which is basically transparent for applications and pretends to be Graphite. So it accepts metrics from clients and on local host, and then does something with them. Usually it's supposed to deliver them to Graphite, to the main one, so we can shut it off, for example, do maintenance, and it's still running, and we don't lose metrics. Then we have quite some more projects. This cluster HC, it's using for example, we are using sometimes Galera MySQL cluster. So for example, that you want to know that node under load balancer is up, and not just up because of port, but it's in sync. And this one is exactly for it. It also supports RabbitMQ and much more. We have much more projects like Sexy. This is for Sentry, if you know it. We have for our Debian mirrors this proxy, which is a lot of things. Pirate, which my colleague will tell you in some minutes about, and much more. Believe me, the only GitHubs are here. You can see they are public, but we also have much more in our very secret internal GitLabs and stuff like this. So yeah, a lot more, including production. And I'm pretty much proud of it that we have already some services running on production in Go. And I just want to quickly explain you about Graph-Z. So as I already mentioned, you have a host, and there is Graph-Z running on this host, and there are applications. Applications are writing transparently to Graph-Z, and Graph-Z does something with this magic and sends it to Graphite. If host is dead, as you can see the red line here, Graph-Z will just keep those metrics until the Graphite is up, and then it will send them back. It's pretty simple, but very powerful tool. Yeah, so it's very small. It's running in on every server. It takes like 4 megabytes of memory. It keeps those metrics in memory or in temporary file, and you can limit how long it keeps them and such. Yeah, so if Graphite fails, it will keep them. It has some aggregation functions. It has whitelist functions, so you cannot send bullshit and trash your Graphite. And it's self-monitoring. It also sends, you can specify the host name that you cannot, for example, overwrite from the client and write bullshit to it that pretends to be different host, for example. This is also supportable. And it's very flexible. Inside, it's simple Go application. You have a lot of channels. You have different routines running in it. And yeah, it's awesome. I will show one more example later. One thing I want to mention, we have IG collect. This is very important part of our inner games. This is basically all our scripts which we use to send data to Graphite. And it also can monitor a lot of stuff. For example, it's already monitoring CPU usage, Redis, MySQL, whatever you can imagine. But it also can do more. It can basically, from Go profiler, it can get the information and send it to Graphite as well. So if you all know, you all love Go, in Go you can enable profiling very quickly. It's like 2 lines of code. And then you will have basically HTTP port listening, and you can connect to it, and you get internal information. You can compare it something with GMX on Java, and then basically you connect to it, and you can see very detailed information, for example, about how long the function took to execute on the CPU, or how much memory it took precisely to the function. So debugging of the code, if you see the application is slow, gets extremely easy. And furthermore, now we have it in IG collect, so running all the time, if you allow for the application, of course. It's running all the time, and you can, for example, someone says, yes, application was slow, or application was doing something weird. You can always see what exactly it was doing this time. And it sends metrics like this. So for example, you have heap information, and then how much which call was taking. I will show a small example. Yeah, so for example, my Graph-Z, as I mentioned already, we have graphs. This is from Graphite. It's taking fresh, like yesterday evening. And for example, this one is showing how many milliseconds each function took. This was very high load. I sent like millions of metrics through Graph-Z just to trigger all of this and see it actually on Graphite. And you can see, for example, that syscall is taking 160 milliseconds. This is quite much, and you can investigate and think, why does it take so much? Maybe CPU is overloaded, maybe something else. And for example, or you can see that regex are taking quite much time. And this is also quite good, because you know that regex in Go, I mean, regex is in every language are broken by design, basically. But here you can see that they are pretty much bottleneck here in this exactly scenario. Or for example, you can see the memory graph. And you can see that, for example, there is a function. Of course, this is not from my Graph-Z directly. This is from dependencies from, for example, Whisper library. But you can see that writer took already 900 kilobytes to write stuff. So it's probably processing some big data. Maybe you can analyze, for example, if you have leaks, if it's growing, for example, yeah, on long term. This is pretty nice. And easy to use. You just need to look at this IG collect. You can just run it on every server. Yeah. If we go for visualization, some people went even further. So you can have those graphs from Profiler, but why not go further and actually visualize your Go routines? So one person did it. You can find the project here on GitHub. It's called GoTrace, and there was a popular article quite some time ago. And basically, this is what you need to run. They have Docker container with a bit patched Go version, and all you need is just basically compile your application inside of this container, and then run 2 commands. And I will show you what they give to you in a second. So we switch to another screen with, where is my mouse? We switch to another screen. Oh, magic didn't happen. Okay, that's, yeah, now I have a mouse. Yeah, so basically this is the command I wrote, go trace and trace, which I prepared already before. And this is about Graph-Z Gesundheit. This is internals of Graph-Z. So I just click the enter, it triggers the browser, and you can see, okay, the black one is not very seeable, but anyway. So you can see that the function main had 3 main Go routines. They are basically server to listen to incoming metrics, client to send those metrics when they are coming through channel, and the third one is monitoring, so self-monitoring. Those are not all Go routines we are interested in, but you can see, for example, the routine which is server, which is accepting metrics. You can see that this one created one more routine, which was listening for a network, and then I start sending those thousands of metrics, and you can see how Graph-Z starts spawning routines. You can see it on visualized model here. So those are incoming connections and basically new Go routines all the time. You can clearly see it on this graph, and you can also see 2 more branches here, if you can see it very nice. I mean, I don't think you can see it, but trust me. Yes, one of them is reading from files. So at the same time, Graph-Z can also read not only from the network that you write to the socket, but also from file. And one of those files got written a lot of metrics, and you can see here the number and the blue line, which is the channel. Basically, the channel was connecting to the client routine, which is used also here by this one. So all this data from all those routines and all those channels are accumulated to one unblocking Go routine, which is sending them and delivering to Graphite, already the big one. So you can visualize any of your applications, I mean, till some complexity, I assume, but I was playing a lot with different projects and it worked very well. So yeah, I kind of liked it very much. Yeah, so that's basically it. That's what I wanted to show. Yeah, if you have a question, yeah, feel free to ask. That's all.